Hi, today I'm going to talk about peer-to-peer chat application model. This is the overview of peer-to-peer chat application. In this project, we are going to build a peer-to-peer chat application. The good news is about this is that we have to write only one program. Yes, but there is also one bad news. The single program is considerably more complex because it does the job of both the client and the server. Now in this peer-to-peer model, there is two overlay networks. The first there is network, the second is overlay network. Now the network defines addressing, routing and the service model for communication between hosts, and the overlay network is built on top of one of the more existing network. So the lines that you are seeing is the network, and this green line that denote is the overlay network. So it adds an additional layer of indirection. This is the peer-to-peer networking. Each participant is a peer and plays an identical role in the system. User cooperatively build this service without relying on the third party to run a server. There are many examples, fast track, code, CAN. So the main difference is that instead of the control is being centralized to a server, it is distributed among all the users. Now for this project, we have to create a socket. So we are going to do with a UDP socket. This is a 3 line of code for creating a socket. Int UDP sock is a variable name where we store the socket. So if UDP socket is less than 0, that means if it is -1 or less than that, so there is an error. So we call this error. A UDP socket, a symmetric server socket and a client socket. So there is no distinction between a server socket and a client socket. Because in peer-to-peer model we require a symmetric, that's why we are using UDP socket. Now you cannot use connect on a datagram UDP socket, so there is no single destination associated with a UDP socket, so each peer uses only one UDP socket. After creating a UDP socket, we have to bind the socket to a port. This is a few lines of code that just binds the socket to a port. We have to store the local addresses and many more lines. This is similar to bind used for a server TCP socket. This is quite relatively the same. Now after binding the packet, we have to send the packet. So this is few lines of code that helps to send the packet. So in the 6th line, the main code goes here, where we store the answer in the variable retval. So basically in this line, we are just sending uh, the packet through a send to function from to a socket address, which is the size of the to socket address. So each packet is individually addressed to a destination address and a port. So retval is equal to packet length doesn't guarantee anything at all. After sending the packet, we have to receive the packet. So this is some few lines of code that can receive the packet. So in the 4th line, this is the main code goes here, where we just receive the packet via receive v from function, and we receive it from the socket address of the host. So we can receive a packet from any other chat peer program on the same socket. The address of the sender is available in the from socket address. After sending and receiving, this is something about programming with the timers. So in this structure, there is a structure called time val, which has two fields, TV seconds and the TV mu seconds. The TV seconds store the result in seconds and the TV mu seconds store the result in the microseconds. So these two fields are just defined in the system/time.h header file. There is a function that compares the time which is stored in the two variable a and b, and we use a CMP, that is compare function. Now compare is a binary comparison operator. We just store less than, greater than, less than, equal to, greater than, equal to, or equal to function. Now when we need to find the address of the machine the program is running on, we can use these lines of code. The local address is included in the header of some packets. Now moving on, now how we can use the select with timeout. To implement this, the fine-grained timers, we must find the earliest time at which the next event has to occur. So we have to do a select function, and we store in the retval variable, and we just wait for the wait time variable. Okay, so this is something regarding the timeout. So if we are going to send a message to any of the participant, then we can just wait for a fixed amount of time to have the answer from the participant. So if we do not get any kind of answer, so there is a timeout, and we can just move on to the next participant who is available to chat with us. Moving on to the main structure of our program, this is two parts, ORL and ML. So in this flowchart box, the lowermost box is the IP address. Above that we have the UDP socket, which is peer-to-peer socket. Above that we have overlay routing layer, and above that we have the messaging layer. So the top two part is the main structure of our program that we are going to write in the chat peer application. So there is a question that why do we need two kinds of layer? Why not one? It's simple because it's a natural way to think about the program. Also, it's because it's a good way to think about and organize your program. And it's easier to write in this way. Hopefully, we can get time to understand the layering concepts better when we go on through. I'm talking about the first description, that is ORL. This helps to route a packet from one end to the other end on the overlay. So as the name suggests, it's an overlay. So it maintains the topology of the overlay, recover from failures of the nodes on the overlay. So it provides the best effort packetting forwarding service. Now moving on, there was the second description, that was ML. Now it deals with the user input and output system, uses the services provided by the ORL to send packets to the other users. So basically this ML implements the retransmissions and the timeouts. Now how does the addressing happens in the ORL? This is one of the important questions. So it just basically happens to a data structure that is hash function. So we are going to implement a hash function here. So addressing in the ORL is in terms of 32-bit identifier, which is similar to the IP addresses, and addressing in the ML is in terms of the username, which is similar to FQDNs. So we simply use a hash function to map the usernames to the identifiers. So this is the overlay topology, where we can, it's just the picture of the 6-bit circular identifier space, and the right picture is about the virtual ring topology in the overlay. So here comes the concept of the successor node. Now the successor node is best explained in the next slide. So in this, suppose we want to get to know the successor node of 60, which is NO. Okay, so if we want to get the successor node of first, so it is written N10, so it directly moves on to N10. So for example, if we take the successor node of 22, we get to the N20. Okay, so packet forwarding algorithm. This is one of the major algorithm that we are going to implement. First of all, there is a wrap between function, which takes in 3 arguments, L, H, and X. L and H is the lower and the upper bound, and X is the variable which we are going to compare, whether it is in between L and H or it is outside L or H. So if this x is between L and H, that is L is less than H, so we will return if if L is greater than X and if H is less than X. So, or else if L was greater than H, then we simply see that whether X was greater than L or X is less than H. Accordingly, it returns the value. Now the main forward algorithm is here, which consists of a if statement and a else simply. An if statement, we have two if conditions. It has to run any one of them. So if wrap between function is fine, or if destination is equal to node, we will just run the if part, or if both of them are wrong, then we will run the else part. So if it is not between the wrap between function, then and the destination world is not equal to node ld, then we will run the else part, where we will send the packet to the successor node at address A. So this is the algorithm. I'm talking about the retransmission timeouts. So there is something what happens that whenever you send some of the messages, there is retransmission. Suppose a timeout occurs, and if you send the next messages, so there may be a chance that the message got sent twice. So we have to avoid printing the same messages twice. So for this, we maintain a window of the past history where we see whether the message was sent or not. Accordingly, we select to avoid if we are just sending the messages twice. So this is all about the peer-to-peer connection, where we have seen how to construct the simple chat peer model. That's all for today. Thank you.